Welcome to Midnight Science, and tonight we wander somewhere strange and quiet. Physicists have begun to wonder if space-time itself is not fundamental, if beneath it lies a deeper geometry, a shape older than space, older than time. Tell me softly, where are you tonight, and what hour has found you? A gentle like and subscribe helps this small, sleepy channel keep drifting along. Somewhere in the room where you are now, there is a table. Perhaps it is beside you. Perhaps it is in front of you. Perhaps it is only in your memory, the low wooden one from the living room of your childhood, or the small one by your bed, or the desk you sit at in the daytime and try not to think about in the evening. Wherever it is there. It has a surface. It has a weight. If you set a cup of tea upon it, the cup stays. If you rest your hand upon it, your hand stays. Nothing about the table asks anything of you. It simply holds what you place upon it, quietly, without complaint, hour after hour, night after night. And this is a lovely thing. When you stop to notice it, the table does not flicker, the table does not drift, the table does not ask for your attention. It is, in the softest possible way, absolutely reliable. It is one of those small, honest presences in a life that make the rest of the life feel possible. So let us begin there, tonight, with the table, with your hand upon it, or your cup upon it, or the small pool of lamplight upon it, with the felt sense of solidity, that quiet confidence you carry through your days without ever quite naming, that the ground will hold you, that the walls will stay where they are, that the hours will tick gently past in the order you expect them to. The chair beneath you, the floor beneath the chair, the building beneath the floor, the earth beneath the building, all of it patiently in place without any effort on your part. This is the world we live in, or at least this is the world we feel we live in. And it is a soft and steady kind of world, the kind of world in which you can settle down, close your eyes, and trust that things will still be arranged more or less the same when you open them again. Now, wherever you are tonight, whether you are tucked under a blanket in a quiet room, or half awake on the sofa with a lamp still burning across the way, or on a long train ride watching the world pass in the dark, or lying in bed with the ceiling above you doing that gentle, unfocused thing ceilings do at night. Hopefully, you are warm, safe, and settled enough to wander with me for a while, because tonight we are going to sit with a very old and very strange question, and we are going to sit with it slowly. The question is this: what if the space you are moving through and the time you are measuring are not the deepest layer of the world? Now, before your shoulders tighten, let me say this softly. The table is still solid. The floor is still holding you. The building is still standing. Nothing about tonight's wandering will take those things away. Whatever we discover together over the next hour or two, the cup will still be where you left it, and the walls will still be where they were built. This is not that kind of story. This is not the sort of question that dissolves your evening. It is the sort of question that quietly widens it. Because for a long time now, physicists themselves have begun to sit with the same wondering, not in a panic, not with any great drama, just softly, In offices and lecture halls and small conversations across long tables, the same idea keeps rising to the surface. That space, the space we walk through, and time, the time we measure with clocks and heartbeats, might not be the bottom layer of things. They might be more like the surface of a pond, calm and continuous from where we stand, but arising from something quieter and stranger underneath. That is where we are going tonight. Slowly, gently, with plenty of room to drift. But before we go anywhere at all, let us stay with the ordinary for a little longer. Let us stay with the table, the room, the cup, the soft weight of your body in the chair or in the bed. Because to wonder about something as vast as space and time, we have to start from the small and the familiar. And there is nothing more small and familiar than the felt sense of being right here, right now, in this quiet corner of the world, with the evening drawing gently in around you. Notice, if you like, the shape of the room you are in, the corners, the doorway, the way the light rests on the walls. Notice the little sense you have of where the ceiling is above you, even if you are not looking at it. Notice the sense of floor beneath the chair, of chair beneath you, of you sitting quietly inside a small pocket of arranged space, with things above and below and to either side, all of it holding still while you rest. This felt sense of the room, this quiet confidence in the geometry around you, is one of the oldest things a mind can have. Long before anyone knew what the stars were, long before anyone had a word for gravity, long before the first cup was set upon the first table, human beings knew what space felt like. They knew what up was, and down, and near, and far. They knew what the passing of the day was, and the coming of the night, and the slow rounding of the seasons. These things did not need to be discovered. They simply were. And for most of our history, the world seemed to be arranged in exactly the way it felt. There was space, which was the big empty room in which things happened. There was time, which was the steady flow along which things unfolded. And there were things which moved through the space, along the time, doing what things do. This is the picture most of us still carry, gently, in the back of our minds. And it is the picture that the great old physicists carried too, at least at first. So let us bring one of them into the room with us, softly, and let him keep us company for a while. His name was Isaac Newton, and he was, by most accounts, a strange and rather solitary man, who lived a long time ago in England, and who spent an enormous amount of his life alone with his thoughts. He had a mind that liked to sit with a single question for years at a time. He wrote long, careful books in beautiful, careful Latin. He worried a great deal about many things, some of them scientific, some of them not. And in the middle of all this, patiently and quietly, he built a picture of the world that would guide physics for almost 300 years. In Newton's picture, space was a vast stage. It was there before anything happened upon it, and it would still be there if everything happened to leave. It did not depend on the things inside it. It did not shift or flex or care. It was, in his gentle old phrase, absolute, a great still theatre in which the play of the world could unfold. And time, for Newton, was a river, a steady, even, unhurried river, flowing at the same rate everywhere, without ever slowing or speeding for anything. If you set a clock in London and another clock on the moon, they would keep the same time forever, without argument. Time simply flowed, the same for all, uncaring and calm. This picture is very close to the one we live inside without thinking. The room is here, the night is passing, space holds, time moves, and for centuries, this was more than enough. It explained the falling of apples and the orbits of planets and the tides of the sea and the arc of a thrown stone. It was, by any reasonable measure, a lovely picture. But nature, very politely, was not quite finished with us. And this is where another quiet companion joins us in the room. Sitting softly at the edge of the light, a man with untidy hair and a somewhat distracted expression, who worked patiently in a small office in Switzerland while doing another job entirely to pay the rent. His name, of course, was Albert Einstein. And he had, among many other gifts, an extraordinary ability to imagine what the world might feel like from strange places, from inside a falling lift, from the surface of a beam of light, from the point of view of something moving very fast, in a way no human body had ever quite moved. And in his patient wondering, Einstein began to notice something, that Newton's steady river of time did not quite behave the way Newton had thought. That clocks moving at different speeds ticked at different rates. That clocks resting at different heights in a gravitational field ticked at different rates. That the great, still theatre of space, which Newton had imagined as fixed and absolute, was in fact quietly flexible, quietly responsive, quietly alive. Einstein gently folded space and time together into a single fabric he called Spacetime. Not two separate things, but one continuous cloth, in which the near and the far and the past and the future were all woven together into one soft geometry. And that cloth, he showed, could bend. It could stretch. It could sag under the weight of stars, the way a soft bed sheet sags under a placed stone. And what we had been calling gravity, that quiet pull that keeps you in your chair, was simply the gentle curving of that fabric near heavy things. This was, in its own quiet way, one of the loveliest ideas anyone had ever had, and the world it described was still, in a sense, familiar. There was still a stage, though it had become a supple one. There was still a flow of time, though it had become a personal one. Things still moved through space. Space still contained things. The picture had softened and deepened, but it had not dissolved, and for a long time, this seemed to be the end of the story. The old still theatre had been replaced by a gentler curved one, and the world made sense again in a slightly stranger way. But nature, once again, was not quite finished, because in the same century that Einstein was folding space and time into a single cloth, another kind of physics was rising, quietly and rather awkwardly, at the small end of the world of atoms and particles, of things so small they no longer had the decency to sit still and be looked at, of things that behaved in ways that were not so much strange as almost polite in their refusal to fit into any old picture at all. This was the world of quantum mechanics, and it turned out to be very difficult in ways that took a long time to name. To make quantum mechanics and Einstein's beautiful curved space-time sit comfortably in the same room. You do not need to hold on to why tonight. You only need to know that when physicists try to imagine what happens at the very smallest scales, where gravity and the quantum are both important, the old picture began to shimmer. The soft curved cloth of space-time, so lovely from a distance, began to look less like a fabric and more like a rumor of a fabric. It began to look, when pressed hard enough, as if it might not be there at all in the way we had assumed. And from many different corners of physics, over many quiet decades, a strange suggestion kept rising to the surface. That space-time might not be the foundation of things, that it might be something that emerges, the way the smooth surface of a pond emerges from the countless smaller motions of the water beneath. That the space you are sitting in and the time that is passing around you might be the calm and continuous appearance of something older and stranger just below. Let me say that again, softly, in slightly different words, because it is one of those ideas that likes to slip away if you set it down for a moment. The world you feel around you, the room, the walls, the passing hour, the shape of the space itself, might not be the deepest layer. Beneath it, there may be something else. Not another kind of space, not another kind of time, but something more fundamental, from which space and time themselves quietly arise. This is not a claim that the world is fake. It is not a claim that the table is not real. It is a gentler and stranger idea than that. It is the suggestion that the table and the room and the sky are real in the way that a rainbow is real, or a wave on the sea is real, or the surface of a pond is real. Real and there and reliable enough for a life, but not the deepest thing. And the physicists who have begun to sit with this idea are not sitting with it in a panic. They are sitting with it patiently, in offices and small studies, over long, careful arguments, in seminar rooms, in equations that stretch across many pages, in gentle disagreements with old friends. They are not certain. They are wondering. And the wondering itself has become one of the softer and more interesting things happening in physics right now. We will spend the rest of this night wandering through some of the shapes that wondering has taken. We will visit a pond and think about what it means for something to emerge. We will visit a lamp on a wall and think about the strange idea that the whole three-dimensional world might be quietly encoded on a surface. We will visit a folded piece of paper and think about a shape that has begun to whisper answers to physicists without ever mentioning space or time. We will visit a written letter and think about the idea that the universe might, at bottom, be made of information. And in the end, we will come back here, to this room, to the table, to the cup, and see what it feels like to sit in a world that might rest on something we cannot yet quite see. But for now, let us just stay a little longer with the ordinary, with the felt sense of the chair beneath you, with the small weight of your hand, or the soft warmth of the cup, or the quiet way your body has settled into the evening. Let us not rush anywhere at all. Let us let the strangeness sit at the edge of the room like a familiar cat, curled up in the shadow, not asking anything of us just yet. Because whatever we come to think about the deep structure of the world, this small pocket of arranged space, this quiet room, this settled body is still here. The table is still solid. The floor is still holding you. The night is still passing gently outside. Nothing about the wandering removes any of it. If anything, the wandering makes it more tender. Because if the smoothness of the world is a kind of quiet gift, arising softly from a deeper strangeness we do not yet understand, then the ordinary reliability of things becomes, in its own way, one of the more astonishing features of being alive. So let us leave the question open for the night and follow it slowly and see where it takes us. If space-time is not the deepest thing, then what is? If the room you are in is a kind of calm surface arising from something quieter beneath, then what is that quieter something? And what shape, if any, does it have? These are the questions we will wander toward. Not to answer them, no one alive can answer them yet, but to sit with them for a while, gently, in this small pocket of evening, with the table nearby and the cup nearby, and you settled softly into whatever chair or bed or corner of the world has become your resting place for tonight. Take a slow breath, if you like. Notice, once more, the shape of the room around you, the floor beneath, the ceiling above, the quiet arrangement of near and far. And let us begin, gently, to wonder what might be underneath it all. Imagine, if you like, a pond at evening, a small one, the kind you might find at the edge of a garden, or in the quiet corner of an old park, or in a wood you walk through once and remember only softly. The light is low, the air is still, the surface of the water is smooth in that particular way that water gets when the day has almost finished asking anything of it. If you look, you can see the shapes of the trees reflected in it, and perhaps a first small star, and perhaps the shadow of your own head bent gently over the edge. And then, quietly, a single leaf falls from a branch above and touches the surface. You know what happens next. You have seen it 100 times in 100 small ponds in 100 quiet evenings. A ring of ripples spreads outward from where the leaf landed. A small circle at first, and then a larger one, and then a larger one, moving softly across the water, meeting the ripples from other small disturbances, folding into them, passing through them, spreading on. If another leaf falls, its ripples spread too, and the two patterns cross one another gently in that lovely way that ripples do, without ever really damaging each other, just moving through and continuing on. These ripples are, in every way that matters to your eye, real. They carry energy from the place where the leaf landed to the edges of the pond. They move at their own pace. They interact with one another. They can push a small twig floating on the surface a little to the side. They can lap gently against the stone at the pond's edge. If you dipped your finger into the water, you would feel them as small, quiet pulses. There is no serious sense in which they are not there. And yet, if you were to lean very close and look very carefully, and somehow see beneath the surface into the water itself, you would find that the ripple, in some deeper sense, is not really a thing at all. It is a pattern. It is a shape that a great many water molecules are making together, each one rising and falling a tiny amount as the disturbance passes through, each one returning more or less to where it was before. No single molecule of water is traveling with the ripple from one side of the pond to the other. The ripple is not a small object moving across a pond. It is a coordinated behavior of the water beneath. It is a surface pattern, and if you went deeper still, past the water molecules, into the atoms inside them, you would find that those atoms are themselves patterns in their own strange way, standing wave arrangements of even smaller things, held together by rules that are quite unlike anything you would guess from looking at a pond. And beneath those, patterns again, and beneath those, patterns of a kind we do not yet fully understand. So the ripple, which felt so real, and which was real, and which really did carry energy across the water, turned out not to be at the bottom of things. It was a surface, a calm and continuous and honest surface, but a surface all the same. Now, of course, the metaphor of the pond is only a metaphor, and it must be handled carefully, in the way that all metaphors must. The pond has water beneath it, and the water is a substance we know how to talk about. The world we are wondering about tonight is stranger than that. Whatever might lie beneath space and time is not, as far as anyone can tell, another kind of substance in the ordinary sense. So we should not push the pond too hard. We should let it be a soft guide, not a strict map. But as a soft guide, it is a very good one, because it lets us hold in one gentle image the idea that a thing can be real and reliable and still not be the deepest layer of what is. This idea in physics has a name. It is called emergence, and it is one of the quieter and more beautiful ideas in the whole of science. Emergence is the soft observation that many of the things we treat as basic in daily life are actually surface behaviors of something deeper. A room's warmth, for instance. The gentle warmth you feel now, if the room around you is warm, or the coolness you feel, if it is cool. That temperature, which feels like such a simple property of the air, is not really a thing the air possesses. It is a summary. It is the average energy of the countless small molecules of air jostling and colliding with each other around you. Warm air is air whose molecules are moving faster. Cool air is air whose molecules are moving more slowly. There is no additional ingredient called warmth that has been sprinkled through the room. The warmth is what happens when a great many small motions are gathered together and their average is taken. And yet the warmth is real. It touches your skin. It rises from the radiator. It seeps through the cup of tea into your fingers. It is not an illusion in any dismissive sense. It is simply not fundamental. It is emergent. It is a soft calm above a great deal of small unseen motion. The same is true of the solidity of the table you thought about earlier. The table feels solid because when your hand rests on it, the atoms in your hand and the atoms in the table push against one another with quiet, stubborn force, held apart by the rules of quantum mechanics, refusing to occupy the same space. If you could zoom in far enough to see the atoms themselves, you would find that they are, by any ordinary measure, mostly empty. Vast, quiet gaps between very small centers of stuff. The table, as a solid object, is not a densely packed brick of matter. It is a pattern of arrangements, held together by fields and rules, whose overall effect, at the scale of your hand, is a lovely, reliable firmness. The solidity, then, is emergent. It is real. Your hand does not fall through the table. Your cup does not sink into it. It is trustworthy in exactly the way solidity ought to be. But it is not, at the deepest level, a bare fact about the world. It is a surface story arising from a much more intricate story underneath. And once you begin to notice this, you find emergence everywhere. The wetness of water, the color of a leaf, the sound of a note played on a piano, the way a flock of birds turns as one across an evening sky. All of these are patterns that arise from smaller ingredients behaving in coordinated ways. All of these are real. All of these are trustworthy. And all of these are, in their own quiet way, not the bottom of things. So the idea has, over time, become a familiar one in physics, that the things we notice and the things we can measure with our instruments may often be the calm surface of something more fundamental beneath. And once this idea is in the room, a natural question drifts up like a small bubble in still water. Might space-time itself be emergent? Might the space we move through and the time we measure be, in this same soft sense, a surface pattern above something deeper? Let me say that gently again, in slightly different words, because it is the kind of idea that likes to slip away if you set it down too quickly. The space around you may not be a fundamental fabric of the world. It may be a summary, a pattern, a soft, continuous appearance that arises when many small ingredients, whatever they are, behave in a particular collective way. And the time you feel passing, gently, as the evening deepens, may not be a fundamental river flowing beneath everything. It may be another summary, another pattern, another emergent behavior of the world. This is not, please notice, the same as saying that space and time are illusions in the flimsy sense of the word. The ripple on the pond is not an illusion. The warmth of the room is not an illusion. The solidity of the table is not an illusion. These things really do behave the way they behave. They can be measured. They can be trusted. So too in this picture with space and time. If they are emergent, they are still real. They still carry the world along. They still hold you in your chair. They still let the evening pass around you. It is only that they may not be the deepest layer of what is. This suggestion is not new. In fact, it has been rising in the minds of physicists for many quiet decades. And there is one companion in particular I would like to bring into the room now, softly, and let sit for a while with us. His name was John Archibald Wheeler. Wheeler was, by all accounts, a warm and unusual man. He worked in the middle of the 20th century, at a time when physics was going through some of its stranger passages, and he had an unusual gift. He liked to sit with strange questions for a long time. He liked to give them soft names. He liked to hold ideas in his hands, gently, and turn them over, and ask what they might look like from another angle. He was one of the people who helped bring the name black hole into common use, though he did not invent the objects themselves. And in his later years, he began to wonder more and more openly whether space and time might be built out of something more primitive. He did not always know what to call the more primitive thing. Sometimes he spoke of information, of bits, of yes and no answers at the base of the world. Sometimes he spoke of geometry, of shapes and relationships beneath the ordinary geometry of space. Sometimes he spoke of things for which no name yet existed and gave them soft placeholder phrases. He did not, in any of this, claim to have solved anything. He was, in his own words, an old man wondering. But he wondered patiently and openly and out loud, and in doing so he helped make it acceptable for other physicists to sit with the same wondering. He was not alone. Other physicists across the same century had been pressing on the fabric of space-time and finding it, in strange ways, less firm than it looked. And by the time the century turned, the wondering had become a small, quiet chorus. Not a shout, not a revolution, just a growing number of soft voices asking, what if the space we move through is not the ground floor of the world? What if there is a lower floor, or something that is not quite a floor, beneath? There is one particular scale at which this wondering becomes especially insistent. Physicists have a name for it. They call it the Planck scale, and it deserves, tonight, a moment of gentle attention. The Planck scale is the scale at which our ordinary picture of space and time begins. In the words of the physicists themselves, to stop making sense, it is the scale at which the smoothness of space-time, so obvious to your eye and to your body, seems no longer to hold. Down there, at that unimaginably small level, the mathematics that we use to describe space and time begins to give strange answers, or no answers at all, or the same answer many times over in ways that cannot all be right. Something changes, something breaks, or, more gently, something surfaces from beneath. How small is the Planck scale? Well, it is small in a way that ordinary words are not quite equipped to hold. So let me offer, softly, a scale translation, not to make you hold the numbers, but just to lean the idea into a shape you can feel. Imagine, if you like, an atom. Just an ordinary atom, one of the small, quiet building blocks of the room around you. An atom is already very small. If you took an atom and made it as large as your entire home, and then walked into that enlarged atom and looked around, you would still be in a fairly empty room, with a very small, dense point somewhere in the middle. Now, imagine taking that atom and making it not the size of a home, but the size of the entire Earth, the whole planet, the size of one atom blown up to fill the space of the world. And then, inside that atom, you would want to find something at the Planck scale. And even in that atom, blown up to the size of the whole Earth, the Planck scale would still be a very small thing, on the order of a single soft grain tucked somewhere quietly inside. That is how far beneath our ordinary experience the Planck scale lives. That is how many layers of smallness sit between the world you feel and the world where space-time begins to lose its shape. Do not try to hold that image. Let it drift past. All that matters is the soft sense of it. Very far down, very far beneath the ordinary, at scales that are almost outside the imagination, the smooth, continuous cloth of space and time seems to stop being cloth at all. It seems, at that depth, to be doing something else. Physicists are not entirely sure what. But almost everyone who studies this question agrees that whatever is happening down there is not simply more of the same. It is not smaller space and smaller time. It is something different, something from which space and time themselves seem to arise. This is where the pond metaphor returns, softly, and pays for itself. Because the ripples on the pond are, in a sense, the top layer of the water's behavior, the layer we see, the layer that carries the leaf. But if you kept looking, past the ripples, past the water molecules, past the atoms, you would find behavior of a very different kind. Not smaller ripples, not tinier ponds. Something else. Something that gives rise to the ripples but is not itself rippling. In much the same soft way, physicists suspect whatever is happening at and below the Planck scale is not smaller space-time. It is something else. Something that gives rise to space-time but is not itself space and time in the ordinary sense. And this is a strange thing to sit with, because it means that the world you are in is, in a sense, layered. The layer you live in, the layer of ordinary rooms and cups and tables and evenings, is a real and continuous surface. It is trustworthy. It is honest. It is the layer at which your life happens. And beneath it, quite far beneath it, at scales so small they have almost no meaning to a human body, there is something else, something that is not space exactly, something that is not time exactly, something that quietly holds up the layer you live in the way the water quietly holds up the ripple on the pond. You do not have to imagine what that something is tonight. No one alive can imagine it clearly. That is part of what makes the current moment in physics such an interesting and gentle one. There are many possible pictures being drawn in many small studies, on many quiet blackboards, and we will visit some of them softly in the coming parts of the night. But for now, all that matters is the shape of the idea, that the space you feel around you may not be the ground floor, that there may be something below. And I want to say again, before we drift on, that this does not make the world thin, it does not make the room less warm, it does not make the table less kind to your hand. If anything, it makes the world tenderer, because the world in this picture is not a bare stage. It is a soft achievement. It is a quiet gift, arising every moment from something deeper. The smoothness of your evening, the reliability of the floor, the way the light stays where you left it, these are not the flat properties of an inert stage. They are the surface calm of a much stranger stillness beneath. That, in a way, is the small emotional heart of tonight. The world is real and emergent at the same time. These are not opposites. A ripple is real, a warmth is real, a solidity is real, and each of them, patiently, arises from something not quite of the same kind. So too, perhaps, with space and time, real and reliable, and always there when you need them. And also, at the very bottom, arising from something we are only beginning to glimpse. Let us stay with the pond a little longer. The evening has deepened. The trees are darker now against the sky. The reflected star is a little brighter. The ripples from the leaf have long since spread to the edges of the water and faded gently back into stillness. If you dipped your hand into the pond now, the water would be cool and quiet. If you looked closely at its surface, you would see it settled again, as if the leaf had never fallen. And yet, deeper down, the water is still there, made of the same molecules, made of the same atoms, still doing all the small unseen motions that make its calm surface possible. That is the picture we will carry with us into the next parts of tonight's wandering. A calm surface, quietly held up by something more intricate beneath. A world you can trust, resting on a world you cannot yet see. A room that is real, in a way that does not require it to be the deepest thing. And beneath the pond, of course, there is the water, and beneath the water, the molecules. And beneath the molecules, other patterns, other geometries, other ideas we have not yet named. Somewhere down there, if we keep listening, we may begin to hear the first quiet whispers of what the world is actually made of. But that is for the parts to come. For now, let us just breathe with the pond for a moment longer. The evening is here, the surface is smooth, the star is reflected in the water, and you are still here, in your chair or on your sofa or in your bed, held gently by a floor that is held gently by an earth that is held gently by something we do not yet fully understand. And all of it, in its own soft way, is real. Somewhere in the room where you are now, there is a source of light. Perhaps it is a small lamp on a nearby table, glowing softly in the evening. Perhaps it is a candle you lit earlier, its flame moving gently in the air. Perhaps it is only the pale blue light of the screen you are watching, resting quietly against your face. Wherever the light is coming from, notice, if you can, what it does to the room around you. Notice the way it falls upon the walls. Notice the way it draws shapes on the floor. Notice the soft shadow it makes of your own hand when you move it slowly through the air. There is something quietly strange about a shadow. A shadow is flat. It lives on a wall, or on a floor, or on the ceiling above you. It has no depth of its own. And yet, when your hand moves in front of the lamp, the flat shadow on the wall moves too. And it moves in a way that carries a great deal of information about the three-dimensional hand that made it. The shape of the fingers, the bend of the wrist, the slow curl of a movement, all of it encoded softly on a two-dimensional surface. Of course, a shadow is only a rough sketch of the hand that made it. It is missing a great deal. You cannot tell from the shadow alone whether the hand is warm or cold, or the exact color of the skin, or how many veins run along its back. The shadow is a poor and gentle summary, but it is enough to make you begin to wonder. Can a surface carry a story about the volume that made it? Can a flat pattern quietly hold information about something with depth? The physicists we are going to sit with tonight, in this part of our wandering, began to ask a much stranger version of that same question. Not about hands, and not about shadows in the ordinary sense, but about the world itself. They began to wonder whether the three-dimensional room you are sitting in, the whole warm volume of the space around you, might, in some very deep mathematical way, be encoded on a two-dimensional surface somewhere, a surface you cannot see from inside the room, a surface that surrounds it quietly, without your ever quite noticing. This idea, when they first began to explore it, seemed almost too strange to say out loud. It felt like the kind of thing you might mention at the end of a long day in a quiet office with the door closed, only to a very trusted friend. And yet, over time, it has become one of the most seriously studied ideas in modern physics. It has a name. It is called the holographic principle, and it is, in its own soft way, one of the most astonishing suggestions anyone has ever made about the world. Let us come to it slowly, because the road that led physicists to this idea is a strange one, and it begins in what may be the least cozy place in the whole of the universe. It begins with black holes. A black hole, as you may know, is a region of space where gravity has become so powerful that nothing, not even light itself, can escape from a certain boundary around it. That boundary has a name. It is called the event horizon. If you were, in some very unwise mood, to cross the event horizon of a black hole, you would not be able to send a message back. You would not be able to shine a torch back at the world you came from. The horizon would quietly close behind you. You would be, from the outside, gone. This is not, please notice, the setting for tonight's story. We are not going anywhere near a black hole. We are staying safely in your chair, or your bed, or your sofa. But the physicists who first began to think seriously about the holographic principle were thinking about black holes, and it is worth understanding, softly, why. For a long time, black holes were something of an embarrassment for physics. They seem to swallow things, and to swallow with them all the information those things carried. A book falling into a black hole seemed simply to vanish. A cup falling in seemed simply to vanish. Whatever fell in was, as far as anyone could tell, lost. And this bothered physicists a great deal, because in the rest of physics there is a very old and very deep principle that information is not supposed to be lost. It can be scrambled, it can be spread out, it can become very difficult to read, but it is not supposed to be destroyed. That would be, in a certain sense, a violation of one of the quiet promises the universe seems to make to us. So a group of physicists began to worry softly about what happens to the information that falls into a black hole. And in the course of that worrying, one of them, a thoughtful and rather gentle Dutchman named Gerard ter Hooft, and another, a warm and imaginative American named Leonard Susskind, began to suggest something extraordinary. They began to suggest that the information about everything that had ever fallen into a black hole was not, in fact, lost. It was written, in a strange and subtle way, on the surface of the black hole itself, on the event horizon, on that flat, quiet boundary at the edge, not inside, not distributed through the interior, on the surface. Let me say that softly again, because it is one of those ideas that seems almost to slip away as soon as you look at it. Everything that has ever fallen into a black hole, everything that has been swallowed by it over its whole long life, is, in some sense, encoded on the boundary that surrounds it, not thrown inside, not scattered through the volume, written on the surface. The three-dimensional history of what fell in is stored as a two-dimensional pattern of information on the horizon. This alone would be an astonishing enough idea to sit with for a lifetime. But Ter Hooft and Susskind, in their patient and slightly mischievous way, went further. They asked a soft and dangerous question. What if this is not only true for black holes? What if, in some deep sense, it is true for any region of space at all? That is what they gently proposed. That any region of space you can imagine, a small pocket of a room, a whole room, a house, a city, a planet, a galaxy, the whole universe itself, might in principle be described completely by information living on the boundary surrounding it. That the interior of any volume of space might be, in a certain mathematical sense, a translation of a pattern on its surface. That the three-dimensional world you are sitting in might be, at the deepest level, a projection of information that lives on a two-dimensional edge somewhere beyond it. This is the holographic principle, and it is, in its own quiet way, one of the strangest ideas physics has ever seriously entertained. Now, before you tighten a little at that, let me say something gently. This does not mean the room is fake. This does not mean your body is not really there. This does not mean the cup on the table is a trick. The holographic principle is not in any dismissive sense an accusation that the world is unreal. It is a stranger and softer suggestion. It is the suggestion that the world you are in and the surface that surrounds it might be two ways of describing the same thing, two languages for the same story, two sides of the same soft coin. Think of it, if you like, in this gentle way. Imagine that a piece of music can be written down as a series of dots and lines on a page, or played out loud as a sound that fills a room. The dots on the page and the sound in the room are very different. One is flat and quiet and made of ink. The other is three-dimensional. It moves through space. It makes your body feel things. and yet they are the same music. The score and the performance are two forms of the same underlying pattern. Neither is fake, neither is more real than the other. They are two ways the same music can appear. The holographic principle suggests something a little like this: that the three-dimensional world you feel around you and the two-dimensional pattern of information on a boundary somewhere might be, in some deep sense, two forms of the same thing. Neither is fake. Neither is more real than the other. But one of them, the boundary, may in some sense hold the whole story, while the other, the interior, may be the way that story appears when it is played out. This idea sat for a while in the softer corners of theoretical physics. It was serious, it was interesting, and it was strange enough that many physicists were not quite sure what to do with it. And then, in the late 1990s, something rather astonishing happened. A young Argentine physicist named Juan Maldacena, working patiently on a set of equations, found a specific mathematical example in which this holographic relationship worked precisely. Maldacena was not trying to prove the holographic principle. He was working on something else entirely, sitting with a particular problem in the mathematics of string theory. And in the middle of his patient work, he noticed that a particular kind of universe with gravity in it, a certain shape of curved space, seemed to be mathematically equivalent to a very different kind of universe without gravity, living on its boundary. Two different theories, in two different numbers of dimensions, with two different collections of ingredients. That turned out, when you looked closely, to be describing exactly the same physics. The universe with gravity had more dimensions than the one without. The universe without gravity was, in a certain sense, on the surface of the one with, and every question you could ask in one language turned out to have a translation into the other. Anything you wanted to know about the interior, with all its gravity and curving of space, could in principle be answered by looking only at the pattern of information on the boundary, and anything you wanted to know about the boundary could in principle be answered by looking at the interior. This result, when it appeared, was one of the quietest revolutions in modern physics. It was not announced with fanfare. It was written down in a careful paper, using careful equations, and it began to spread slowly through the community, being tested and doubted and probed and confirmed. And over the years since then, it has become one of the most extensively studied ideas in the whole of theoretical physics. It has not been proved to describe our universe. It is, so far, a beautiful mathematical example in a somewhat idealized setting, but it is a working example. It is a specific, precise, checkable case in which a world with gravity is genuinely equivalent to a world without gravity living on its boundary. And that, quietly, is enormous, because if the holographic relationship really can hold in this precise way, even in an idealized setting, then it is at least possible that something like it holds in the real world. It is at least possible that the three-dimensional universe we live in is a kind of soft translation of information living on a two-dimensional boundary somewhere. It is at least possible that gravity itself, the very quiet pull that keeps you gently in your chair, is a way that certain patterns of information appear when they are viewed from the inside. Let me say that gently again. Gravity, in this picture, is not necessarily a fundamental thing that lives at the bottom of the world. Gravity may be a translation, a way that information on a boundary shows up as a curved space in an interior, and space-time itself, This soft cloth we have been wondering about all night may be a similar translation. A pattern on a surface, appearing to us from within as a three-dimensional world with a passage of time. You do not need to hold on to the details of any of that. Let it drift through you, softly, in the way that music does when you are half awake. The shape of the idea is enough. The world you are in may be, in some deep sense, a projection. Not a fake, not an illusion, not a joke played on you, but a genuine expression of information that also has another form on a surface somewhere beyond the edge of the room. There is something quietly beautiful about sitting with this idea in a warm room, because the idea itself, if you let it, becomes strangely tender. Every ordinary thing in the room you are in, every corner, every fold of a blanket, every drift of steam from your cup, every quiet motion of the light on the wall, becomes, in this picture, an expression of a pattern that also exists in another form. Nothing here is less real for being expressed elsewhere. It is only that the world becomes, in some sense, doubled. There is the room, and there is the score of the room. There is the shadow, and there is the pattern of information that gives rise to it. And both are real in the way that music is real, and its written score is real, and neither is more real than the other. There is a soft question that often arises here in the quiet hours. If the world we live in is somehow encoded on a surface elsewhere, then where is that surface? Is it somewhere we could point to? Is it near? Is it far? The honest answer is that no one is quite sure, and that the question itself may be one of those questions that softens as you look at it. In the specific mathematical examples, where the holographic principle works precisely, the boundary is not a place you could travel to. It is not, in the ordinary sense, sitting on the other side of a wall. It is more like the outer edge of the mathematical description itself, a place where the equations end, rather than a place where the world ends. And whether our real universe has such a boundary, and where it is if it does, are open questions that physicists are still sitting with, softly, in their offices and in their late thinking. So we should not tonight try to point to the surface. We should not try to imagine walking to it. It is enough to sit with the softer idea that the world you are in, this room, this chair, this cup, this evening, may in some deep sense be the interior expression of a pattern that also exists in another form, on a surface we cannot see from within. There is another gentle way to hold this. Think, if you like, of a photograph of a room. The photograph is flat. It is two-dimensional. And yet, if it is a good photograph, and you look at it for a long time, you begin to feel the depth of the room it shows. You begin to sense the space between the objects, the distance to the far wall, the way the light fell in the moment it was taken. The photograph is not the room, but it holds, in its flat surface, enough information about the room to bring the room softly back to you. Now, the holographic principle is not quite this. It is stranger. It says that the surface does not merely represent the room. It says that the surface and the room are, in a certain deep mathematical sense, two forms of the same thing. Not a photograph of a room, but a room that has two equally real expressions, one in the volume and one on the edge. You are allowed, as you sit with this, to feel a small warmth rise up in you. It is a very gentle kind of wonder, and it is one of the softer gifts of physics in our lifetime. that the world you know may be much stranger than it looks, and also just as trustworthy as it ever was. The lamp in the corner of your room, or the candle, or the pale screen, is still glowing quietly. The shadow on the wall is still moving softly as anything shifts. The room is still holding you. The floor is still holding the room. And beyond the walls, and beyond even the sky, there may be a soft edge to the description of the world, on which the whole three-dimensional story of your evening is, in some sense, written. And you are not less here for that. You are, if anything, more gently held. Let us stay a little longer with the shadow on the wall. Notice its shape. Notice how it moves when you move. Notice how much information it carries about the three-dimensional you that is making it, and yet how quiet and flat it is on the surface of the wall. Now let that image expand, softly, in your mind. Let it grow, gently, until it is not just a shadow on a wall in a room, but the whole idea of a world being expressed as a pattern on a surface. Let the surface be very quiet and very far away. Let the room in which you sit be the projected expression of it. Let yourself be, for a moment, both the volume and the score. Nothing about this changes the warmth of the cup. Nothing about this changes the softness of the blanket. Nothing about this changes the way your breath moves in and out as the night deepens. If anything, everything becomes a little more tender, because to be here, in this small pocket of arranged light and warmth, in a world that might be a projection from somewhere we cannot see, is to be, in a certain sense, a piece of a very quiet piece of music being played out into space. The lamp glows, the shadow moves, the wall holds them both, and somewhere, perhaps, a very quiet surface holds all of it, softly, at the far edge of the world. We do not know if it is really there, but we know, at least in a small mathematical example, that such a surface can exist and can be equivalent to a whole world in its interior, and that alone is enough for tonight to sit with. That alone is enough to wonder about, gently, as the evening deepens further around you. We will leave the lamp on. We will leave the shadow moving softly on the wall, and we will move in the next part of the night from the surface of the world to the shape of it. Because if space and time may not be fundamental, and if the interior of the world may be a translation of information on a boundary, then a further question begins, softly, to rise. What is the shape of that information? What geometry, if any, sits at the bottom of the story? And it is there, in the next quiet room of tonight, that we will meet one of the strangest and loveliest objects physicists have ever imagined. But for now, let the shadow stay on the wall. Let the lamp keep glowing. Let the world be, for a little while, both here and elsewhere, both room and surface, both story and score. And let yourself rest, gently, in a world that may be more like a projection than a stage, and yet is still, in every soft and honest way, warm. Somewhere in the room where you are now, or somewhere in the room you are remembering as we sit here together, there is, or was once, a small folded piece of paper. Perhaps it is a paper crane, made carefully by a patient set of hands, resting quietly on a shelf. Perhaps it is a small folded note tucked into a book you have not opened in a long time. Perhaps it is a shape a child made once, out of a square of colored paper, following the slow steps of a diagram in an old book, and pressed the folds down firmly, one at a time, until a small, crisp geometry emerged in their hands. There is something quietly lovely about a folded shape. It has no need of color, it has no need of decoration. It is just a piece of the world, arranged into a particular geometry, and that geometry, all by itself, is enough to make the shape feel like something. A crane, a boat, a star. The paper has become, through the folds, a small, clean idea, a shape that stands in the world without asking anything of it. Or think, if you like, of a small crystal, a quartz stone from a garden shop, resting on a windowsill, or a piece of ice on the edge of a glass, or the tiny geometric shape of a snowflake, held for a moment on the sleeve of a coat before it melts. All of these are, in their own quiet ways, geometry made visible, shape made into a small piece of the world, and when the sun catches them and they throw a soft shadow onto the floor, that shadow too is a shape, a flatter one, a simpler one, but still a shape, a little geometry drawn briefly on the wood. We have grown up thinking of geometry as something the world contains. We think of the world first as a place, and then of geometry as the small, clean shapes that appear inside it. Circles, triangles, cubes, crystals, cranes. We think of these as decorations of space, small, clean patterns arranged in a much larger and more forgiving stage. Tonight, in this part of our wandering, we are going to sit with a very strange and gentle possibility. That geometry, pure shape, might not be a decoration of space at all. That geometry might, in some deep and quiet sense, sit even deeper in the world than space and time themselves. That underneath the room, and underneath the walls, and underneath the passage of the evening around you, there may be a shape, not a shape in space, not a shape in time, a shape more fundamental than either, a shape that quietly holds the answers to some of the deepest questions physicists know how to ask, and that speaks those answers without ever needing to mention space or time at all. The physicists who have begun to sit with this possibility have a name for one of the strangest examples of such a shape. It is called the amplituhedron. It is, admittedly, not a very cozy word. It sounds rather technical, and it does not arrive carrying a basket of friendliness. But once you unwrap it a little and let it soften in your mind, it becomes one of the loveliest small mysteries in modern physics. Let us come to it slowly, in the way we come to everything tonight, not by leaping to the definition, but by settling into the shape of the story first. For a very long time, physicists have wanted to answer a certain kind of question about the world. When two very small particles meet and interact and scatter off one another, what are the chances that they will scatter in this direction or in that direction, or that a certain third particle will be produced in the process? These are the sorts of questions that the great particle accelerators, the enormous quiet machines buried under the earth in Europe and elsewhere, are built to explore. Small particles are made to meet at very high energies, and their scattering is watched patiently by very careful detectors, and the results are compared with the predictions of physics. To make those predictions, physicists have, for many decades, used a very particular set of tools. These tools rely on a picture in which particles travel through space-time, meet at points, exchange influence, and continue on their way. The mathematics of this picture is beautiful, and it works remarkably well. It has produced some of the most precise predictions in the whole of science. But it has one small, quiet flaw. It is enormously complicated. For very simple interactions, the calculations are already quite involved. For more complicated interactions, involving more particles or more layers of subtle influence, the calculations grow in a way that is, admittedly, slightly inconvenient. A single question about what a small handful of particles might do can require, in the old picture, thousands upon thousands of terms, each one requiring careful computation, each one requiring careful bookkeeping, each one adding, subtracting, cancelling in ways that would take a room full of patient physicists a very long time to finish. And when they finished, they would often find that the final answer, after all of that work, was remarkably simple. All of the enormous complexity in the middle had gently cancelled itself out. For a long time, this was treated as a curious feature of the calculations. Just one of those things. Nature, very politely, had chosen to make the answers simple, even though the road to them was long. Physicists shrugged and did the calculations and moved on. But a small number of them began to wonder, softly, whether the simple final answers were trying to tell them something. Whether the fact that the answers were simple meant that there was, somewhere, a simpler way to see them, a way that did not require the enormous middle, a way that did not require, perhaps, the whole space-time picture at all. Two of these physicists were named Nima Arkani-Hamed and Jaroslav Trunka. Arkani-Hamed is a warm and energetic thinker who has spent much of his career sitting with the deepest questions in physics and refusing to accept easy answers to them. Trunka was, at the time, one of his younger collaborators, patient and careful and quietly imaginative. Together, they began to explore a soft suspicion that the complicated calculations of particle scattering might be, in some deep sense, the surface behavior of a much simpler geometric truth. That there might be, somewhere, a shape whose properties quietly encoded the answers. They were not the first to think in this direction. Many other physicists, over many years, had been noticing hints. There were patterns in the calculations that were too neat to be accidental. There were symmetries that appeared out of nowhere. There were simplicities that arrived at the end without ever having been visible along the way. Slowly, patiently, a small chorus of physicists began to feel that space-time, as the setting for these calculations, might not be the most natural setting at all. That the true home of the answers might be somewhere else, in some other kind of mathematical object, and that space-time was only one of the languages in which the answers could be expressed. And out of this soft chorus, Arkani-Hamed and Trunka, together with their colleagues, gently proposed a specific object, a shape, a higher dimensional geometric figure, sitting outside the ordinary framework of space and time, whose volume, when carefully calculated, gave, in one clean step, the answers that the old space-time picture had struggled through thousands of terms to reach. They called this object the amplituhedron, Let me pause here for a moment, softly, because the idea is worth resting on before we go any further. Imagine, if you like, that you have been asked a question about how a small collection of particles will scatter off each other in a certain experiment. In the old picture, to answer this question, you would begin by drawing many small diagrams. Each diagram would show a different way the particles could interact, meet, exchange, influence, and part again, all inside space-time. You would compute a number for each diagram. You would add them all up. Some would be positive, some would be negative. Many would cancel each other, and after a very long day, you would arrive at a final number, which would be surprisingly simple and which would tell you the probability of a certain outcome. Now imagine that, instead, you were given a strange geometric shape. Not a shape that lives in your room, not a shape you could hold in your hand, a shape that lives in a mathematical space with many more dimensions than the world you walk in. And imagine that, instead of drawing all those diagrams, you were told, softly, to compute the volume of this shape. And imagine that. When you did, the answer that came out was exactly the same simple number the old calculation had struggled toward, without ever drawing a space-time diagram, without ever mentioning a particle meeting a particle in a room, without ever needing time to pass or space to hold anything at all. That, in a very soft sense, is what the amplituhedron does. It is a shape in a higher dimensional mathematical space whose volume encodes the probabilities of certain particle interactions. And the astonishment is not only that such a shape exists. The astonishment is that, once you have it, the answers arrive almost gently, without any need for the machinery of space-time that physicists have been using for 100 years. Let me say that again, slightly differently, because it is one of those quiet shocks that likes to slip out of the mind. In the old picture, to know what particles will do, you follow them through space and time. You watch them move, you watch them meet, you watch them scatter, and out of a great deal of watching, a probability emerges. In the new picture, you do not watch anything at all. You look at a shape, you measure it, and the probability arrives, complete, without any watching, without any movement, without any passage of time. The shape simply is what it is, and its being what it is enough to tell you what would happen in a world where particles move through space-time. The shape does not sit inside space-time. It does not sit anywhere in the ordinary sense of sitting. It lives in a mathematical space of its own, a higher dimensional space with its own strange geometry. And it is, in some quiet way, more fundamental to the answer than the space-time picture ever was. This is a strange thing to sit with, and it is worth sitting with it slowly, because the amplituhedron, so far as anyone knows, is a specific example that works in a very particular corner of physics. It is not, tonight, a proof that all of the world's answers live in such shapes. It is not a claim that the whole of physics can be rewritten this way. It is, admittedly, a single beautiful example in a somewhat idealized setting that shows that at least some of the deepest questions physicists ask can be answered cleanly and precisely by a geometric object that does not live in space or time at all. But that alone is enough to make a person sit up softly in their chair. Because if the answers can be found without space-time, then perhaps space-time is not where the answers live. Perhaps the shape is more fundamental than the stage. Perhaps the room and the evening, so familiar to us, so much the setting of our lives, are only one way of speaking about something that also has another, quieter form. A form that is not a room or an evening, but a shape, a geometry, a quiet architecture, sitting somewhere outside of space and time, that quietly holds within it the answers to how the world unfolds. You do not need to picture the amplituhedron itself tonight. It is a shape in many dimensions, and no honest picture of it will fit into a human room. What matters is the softer idea, that physicists have found a specific example, a real working example of the kind of thing they had long suspected might be possible. A place where the world's answers live in geometry rather than in the passage of time. A place where the shape comes first, and the story of particles moving through space and time is only a translation. And here is where the wondering deepens, softly. Because if this is possible for one small corner of physics, and it is, then it is at least conceivable that something like it is true for a great deal more of physics. It is at least conceivable that the whole story of particles and fields, of matter and force, is, at its bottom, a geometric story. That whatever is really going on in the world is best told not by watching things move through space-time, but by looking at the shape of a certain higher dimensional object. And that space-time itself, with all its rooms and evenings and passages of time, is a soft surface expression of that deeper geometry. Physicists themselves are still sitting with this. No one is claiming tonight that this has been proved. No one is claiming that the amplituhedron is the whole story. Arkani Hamed, in his warm and thoughtful way, has often said that this is the beginning of an investigation, not the end of one. That there are many more shapes to be found. That there is much more geometry hiding in the mathematics of physics than anyone realized. That the amplituhedron is one small window into what may be a very large and very quiet architecture beneath the world. And that the honest response to this, at the moment, is not certainty but patient wondering, which is a lovely thing to be able to say. Because it means that we are in one of those rare and gentle moments in physics when the questions are open, and the answers are only just beginning to be sketched, and no one at the top of the field is pretending to know more than they do. There is a kind of intellectual honesty in the current moment that feels rare and warm and worth appreciating. But even without certainty, the shape of the possibility is enough to change how one thinks about the world. Because it becomes possible to imagine softly that what you feel around you, the room, the walls, the evening, the passage of time, might not be the deepest layer of the story. That there may be, sitting quietly somewhere outside of space and time, a shape, a geometry, a clean, quiet architecture, whose properties are the true source of what happens in the world, and that the world, as you feel it, is what that shape looks like when it is translated into a story that unfolds in space and time. It is worth pausing here for a soft breath, because that is a great deal to have said, and I would not blame anyone listening this deep into the night for feeling that the ideas have grown a little larger than the room. So let us come back to the room gently for a moment. The folded paper is still on the shelf. The small crystal is still on the windowsill. The shadow of the crystal is still resting on the floor, moving slightly as the lamp flickers, as small shadows do. The blanket is still on you. The cup is still where you left it. All of the ordinary geometry of your evening is still perfectly in place, being exactly the geometry you know how to trust. And yet, tonight, there is a small strangeness in the room that was not there before, because it is possible that beneath the geometry of your evening, beneath the shape of the room and the shape of the shadow and the shape of the crane on the shelf, there is a deeper geometry, a shape that is not in this room, a shape that is not in any room at all, a shape that quietly holds a piece of the story of how the world unfolds, and that whispers its answers gently, without ever mentioning the space you sit in or the time that is passing around you. That is a soft strangeness to sit with, and it is a strangeness that does not take anything away from the ordinary geometry of your night. The crane is still a crane. The crystal is still a crystal. The shadow on the floor is still moving softly in the way shadows do. If anything, all of these small, ordinary shapes feel more tender now, because they are, perhaps, the surface expression of something much larger, a geometry beneath the geometry, a shape beneath the shape. Physicists have long liked to say that mathematics is unreasonably effective in describing the world, that the equations they use to describe nature are strangely beautiful and strangely simple, and that the fit between mathematics and reality is closer than anyone has any right to expect. The amplituhedron and the small chorus of geometric objects being found alongside it may be one of the reasons this is so. Because if the world is, at its deepest level, a piece of geometry, then it is not surprising that geometry describes it well. It is only what one would expect. And this, in its own way, is a rather calming thought. Because if the world is geometry all the way down, then the smoothness of your evening is not an accident. It is the surface behavior of a very quiet, very clean, very ancient architecture, sitting patiently somewhere outside of space and time, whose only job, in this small corner of things, is to give rise to the moment you are in. Let us stay a little longer with the folded paper on the shelf. Let us stay with the small, clean geometry of the crane and with the softer geometry of its shadow on the wall behind it. Let us imagine, softly, that behind that shadow and behind the wall and behind the room and behind the evening, there is a shape, a higher shape, a cleaner shape, a shape more fundamental than any of the shapes we can hold in our hands. We do not have to see it tonight. No one alive can see it, but we can gently know that it is there in the mathematics, that physicists have found, in at least one small, careful example, a real working case of a geometry that lives outside space and time, and yet holds within it the answers to how a piece of the world unfolds. And that alone is enough to make the room and the night and the folded paper on the shelf feel like part of something quieter and stranger than they seemed a moment ago. The lamp still glows. The shadow of the crystal still rests softly on the floor. The paper crane still keeps its patient watch on the shelf. And somewhere, in a mathematical space we cannot enter, a strange and lovely shape is doing quiet work on behalf of the world you are sitting in. And the world you are sitting in its own soft way, is doing quiet work on behalf of you. We will leave the shape where it is, for now, and let it keep working. And in the next part of the night, we will follow a different soft thread. Because if geometry can hold the answers, and if boundaries can hold the world, then a further question begins, gently, to rise. Perhaps at the very bottom, what the world is made of is not space, and not time, and not even geometry, but something even softer, something like information, something like the quiet passing of meaning across a great web of relationships. And it is toward that idea that we will drift gently in the next part of tonight's wandering. But for now, let the crane stay on the shelf. Let the shadow stay on the floor. Let the room stay as it is, and rest for a moment in the strange calm of a world that may be geometry all the way down. Somewhere on the table in front of you, or in a drawer nearby, or in a box on a shelf you have not opened in a long time, there is, or there once was, a letter, a handwritten one. Perhaps it is a note that someone left for you in the morning, before you were awake, resting quietly beside a cup. Perhaps it is a postcard from a friend who was traveling somewhere far away. Perhaps it is an old letter from someone you loved once, kept for reasons you no longer entirely remember, but kept nonetheless. There is something quietly extraordinary about a letter when you stop to notice it. It is, at its most physical, only a piece of paper with a few dark marks on it, a little ink arranged in small shapes, resting on a soft, flat surface. It has almost no weight. It has almost no substance. And yet, when you read it, something moves. Something crosses the room. Something reaches from the mind that wrote it into the mind that reads it, softly, through nothing more than ink and paper. That something has a name. Its name is information, and information in physics has begun to become a stranger and more important thing than anyone once imagined. We are used to thinking of information as something we exchange, as something we send. Words on a page, messages on a screen, a voice on the other end of a call. In this everyday sense, information is what lets us know things, what lets us tell each other things, what lets meaning cross the small gaps between minds. It seems, in the ordinary way of things, like a very human sort of ingredient, something we invented, more or less, to keep track of the world. But in the quiet corners of modern physics, a different possibility has been rising, softly, for many decades now. That information may not be something we invented at all. That information, in some deep sense, may be one of the ingredients the universe itself is made of. That underneath the space and time we live in, and underneath the geometry we wondered about a little while ago, there may be, quietly, a great web of information, a quiet passage of yes and no answers, of bits, of small correlated relationships, from which the world we know softly arises. It is a strange idea. It sounds, on first hearing, almost too abstract to be about anything real, and yet the people who have followed it patiently over many decades have found that it keeps leading them to unexpected places, places where the world begins to look less like a stage full of objects and more like a very quiet piece of writing being read continually into being. Let us bring John Wheeler back into the room for a while. We met him earlier tonight, sitting softly with the possibility that space and time might not be fundamental. He was a warm and unusual man, a physicist who liked to sit with strange questions for a long time, and who had a particular gift for putting new ideas into old, plain words. And in the later years of his long career, Wheeler became more and more taken with the possibility that information might be, in some deep sense, the base layer of things. He gave this idea a soft phrase: one that has stayed with physicists ever since. He suggested that every particle, every field, every force in the world might arise, in the end, from an answer to a very simple sort of question, a yes or a no, a 1 or a 0, a single bit of information, and that the whole enormous world, with all its warmth and weight and passage of time, might be built up from an unimaginable number of such small, quiet answers, threaded together in patterns we do not yet fully understand. He was not claiming to have proved this. He was a careful man, and he knew the difference between a proof and a suggestion. He offered it as a late-life wondering, a gentle possibility for younger physicists to sit with if they wished. A soft door left open at the far end of his career in the hope that someone would eventually walk through it and see what was on the other side. And, quietly, over the years since he first said it, more and more physicists have walked through that door. The path that led them there ran, of all places, through the study of black holes. We visited black holes briefly a little earlier when we talked about the holographic principle, and it turns out that black holes, in their strange and lonely way, have been some of the best teachers physicists have had on the question of what information really is. When physicists first began to study black holes seriously, they noticed something strange. Black holes seemed to swallow things. And when a thing fell into a black hole, all of its details, all of the particular arrangements that made it what it was, seemed to vanish from the outside world. Two very different things, thrown into the same black hole, would seem, from far away, to make the black hole look almost identical afterwards. Only its mass, its charge, and its spin would change. The rest, apparently, was lost. This was troubling, because in the rest of physics, information is not supposed to be lost. It can be scrambled, it can be hidden, it can be spread out across many small parts of a system in ways that make it very difficult to recover, but it is not, at the deepest level, supposed to be destroyed. There is a quiet promise running through the whole of physics that the world does not simply forget things, and black holes seem to be breaking that promise. For many decades, physicists sat with this problem, softly and sometimes not so softly, and gradually they began to work out that the promise was not, in fact, being broken. That the information about everything that had ever fallen into a black hole was, in some subtle way, still present. That it was, as we saw earlier, encoded on the surface of the black hole, on its event horizon, in patterns that were extraordinarily difficult to read, but not, in principle, impossible. And as they worked this out, they discovered something else. Something even softer and stranger. They discovered that the amount of information a region of space can hold is limited, not by its volume as one might expect, but by its surface area, by the size of the boundary around it. The bigger the boundary, the more information can be held inside, and the strict limit is set, not by how much room there is, but by how much surface there is to enclose it. Let me say that gently again, because it is one of those ideas that likes to slip. In the ordinary way of thinking, if you want to store more information, you build a bigger container, you add more shelves, you add more drawers, you use the volume of the space. But in physics, when you look very carefully, it turns out that the true limit on how much information a region can hold is not set by its volume at all. It is set by the area of its surface, as if the walls of the container were the true storage, and the interior were only, in some sense, a projection of what the walls could carry. This is a soft echo of what we heard earlier in the part about the holographic whisper, and it is not a coincidence. The two ideas are quietly related, because if the amount of information in a region is limited by its surface, then the interior of that region, whatever it looks like from within, cannot carry more than the surface allows. And the natural way to make sense of this is to say that the surface, in some deep sense, is where the information really lives, and that the interior is what it looks like when it is expressed in 3 dimensions. So we have, in this picture, 3 quiet threads beginning to weave together. That information is not destroyed, that it is held on surfaces, and that the interior of the world may be a translation of patterns of information into a form that looks like space and time and things. And here, softly, is where a further thread joins the weave, a thread that involves a very particular and quite tender kind of quantum relationship called entanglement. Entanglement is one of the strangest features of the quantum world, and it deserves to be handled gently, because it does not fit easily into any picture we have from ordinary life. In the very simplest terms, entanglement is what happens when 2 small parts of the world become linked in such a way that the state of one is deeply tied to the state of the other, even when they are very far apart. It is not that a message travels between them. It is not that one sends a signal to the other. It is that, in some subtle way, they were never quite separate to begin with. Their descriptions are woven together into a single quiet piece of information, and that weaving persists no matter how far apart they drift. This is a genuinely strange thing, and physicists have been trying to make sense of it for the whole of the past century. But in the past couple of decades, a few of them have begun to notice something quite lovely, that the pattern of entanglement between different parts of the world seems to be linked in some deep way to the shape of the space they occupy. One of the physicists who noticed this most gently is a man named Mark van Ramsdonk. He is a thoughtful and careful thinker who spent a great deal of time sitting with the mathematics of the holographic examples we heard about earlier. And in the course of that sitting, he asked a soft and dangerous question. What would happen in these mathematical universes if you slowly weakened the entanglement between 2 regions of the boundary? What would happen to the space between them in the interior? The answer, when he worked it out, was quite tender. As you weakened the threads of entanglement between the 2 regions of the boundary, the space between them in the interior seemed softly to come apart, to stretch, to thin, to eventually pull open, as if the very fabric of the space were made of the entanglement itself, as if space, in that picture, were being woven, moment by moment, from the quiet correlations between different parts of the world. Let me say that again in gentler words, because it is a large idea to be resting quietly in a small paragraph. The distance between 2 regions of space in these particular mathematical universes seems to depend on how tightly they are entangled. Turn up the entanglement, and the distance grows shorter. The regions feel more like neighbors. Turn it down, and the distance grows longer. The regions feel more separate. Turn it off entirely, and the space between them ceases, in a certain sense, to exist, as if space itself were the visible expression of entanglement between things. Now, this is a specific result in a specific setting. It is not, yet, a proof about our own universe. It is another beautiful example, alongside the amplituhedron and the holographic principle, of a case where something we thought was fundamental turns out to be a soft surface expression of something deeper. In that particular setting, space and entanglement seem to be, in some sense, the same story told in two languages. And the fact that this can happen, even in an idealized setting, is one of the softer and more interesting hints modern physics has offered us about what the world might really be like at the bottom. So we have arrived, gently, at a picture. Not a certain picture, not a proved picture, but a picture that has been quietly assembling itself in the corners of physics over the past few decades, and that is worth sitting with for a while. In this picture, information is not merely something we exchange. It is one of the deep ingredients of the world. It cannot be destroyed. It is limited in any region by the surface around it. And it may be, at the deepest level, the material from which space and time are woven. In this picture, the room you are in is not a bare stage full of objects. It is a soft pattern of relationships, a quiet web of correlations between very small pieces of the world that expresses itself at the scale of your body as walls and floors and lamps and cups. The space between you and the far wall is not, in this picture, an empty gap. It is a great many quiet threads of entanglement, linking the little particles that make up you and the little particles that make up the wall, and expressing themselves at your scale as the feeling of distance. And the whole enormous universe in this picture is not a great empty container filled with things. It is a vast, quiet web of information, a great tapestry of relationships, and the space we move through and the time we measure are the soft surface expression of that web, the way it looks from within to a mind that is one of its patterns. You are allowed, as you sit with this, to feel a small hesitation. It is a strange picture to hold, and I want to say, softly, again, that nothing about this dissolves the world. The room is still here, the cup is still warm, or the tea in it is, if you still have any. The blanket is still on you, the floor is still holding you up. Nothing about the possibility that the world is, at bottom, made of relationships takes any of these ordinary things away. It only perhaps changes the way you might quietly notice them. Because if the room is a pattern of information, then everything in it, including you, is part of that pattern. You are not a separate object dropped into a container. You are one of the threads in the weave. The walls, the floor, the cup, the lamp, the shadow, and you are all quietly related, all woven into the same soft fabric, all expressions of the same great quiet web. And the reason the room feels like a place, rather than a chaos, is that the threads of that web are arranged in ways that give rise, at your scale, to the calm, smooth appearance of space. There is something almost tender in that when you let it sit for a while, because it means that the ordinary distance between you and the person you love, or between you and the sleeping animal at your feet, or between you and the small plant on the windowsill, is not really an empty gap. It is a quiet weave of relationships, tying the tiny pieces of you and the tiny pieces of them together softly across the little pocket of the room. The gap is not empty. It is full of quiet correlation. It is the fabric of your closeness. And the sky you sometimes look up at on nights when you are outside, and the far stars in it are not, in this picture, cold objects across a great emptiness. They are threads in the same web. The distance between you and them is a quieter, longer weave. But it is a weave. It is a slow, soft tapestry of information, connecting your small pattern to the far pattern of the light coming down from a place that does not know you exist. And even that, in its own quiet way, is a kind of relationship. Physicists who work on these ideas often say that they think about them, sometimes, at the ends of long days, in ways that spill a little beyond the mathematics. That the picture of a world woven from information can begin to feel, at the edge of thought, like a picture of a world woven from something almost like meaning, not meaning in the human sense of stories, just the older, softer sense in which two things being related is a form of meaning, two things being connected, two things being, in some quiet way, part of the same word. You do not have to follow them all the way there tonight. It is enough, for now, to sit with the softer version of the idea, that the world may be at its bottom more like a piece of writing than like a stage full of objects, that the space you sit in may be more like a paragraph than like a room, that the distance between things may be more like the meaning between words than like the emptiness between shelves. And you, in this picture, are not less real for being one of the threads. If anything, you are gently more so. Because to be a thread in a web of relationships is to be something that only makes sense in company, something whose being here depends softly on the being here of everything around you, something whose place in the world is a piece of the world's own quiet way of being what it is. Let us come back now to the letter on the table, or the note, or the postcard, or whatever small written thing lives somewhere in your life, waiting to be read again on a quieter evening. Notice, if you like, how much passes between the person who wrote it and the person who reads it through only a little ink on a little paper, a great deal of meaning carried by a very small physical trace, a great deal of relationship held gently by a very small pattern. The letter is, in its own soft way, a small parable of the picture we have been sitting with. It is a physical object. It has a shape and a weight, however light. And yet what it really is, in the way we experience it, is a piece of information, a pattern of relationships, a small thread of meaning laid down between two minds. The paper is only the surface. What matters is the weave. The universe, in the pictures physicists are gently sketching in our own time, may be a little like that too. What we experience as objects, as space, as passing time, may be the surface. And what really matters, underneath, may be the weave. A great quiet web of information, a great quiet web of relationships, folding itself into the shape of a world that we can live in. The room is still here. The cup is still where you left it. The letter on the table is still resting quietly, its little marks holding their little meaning, undisturbed by any of tonight's wandering. And you are still where you are, held gently by a chair, held gently by a floor, held gently by a room, held gently, if this soft picture is anywhere near right, by an unimaginably vast and quiet web of relationships beneath. Let us leave the letter where it is, for a moment, and let its meaning rest softly between whoever wrote it and whoever reads it. Let us leave the web where it is, running softly through the room, through the walls, through the sky, through everything you can imagine and everything you cannot. And let us, In the next part of the night, try to bring all of these soft threads together: the pond and the ripples, the lamp and the shadow, the folded paper on the shelf, the letter on the table, and see if we can rest gently in what they all begin together to suggest about the world beneath the world. But for now, let the ink stay on the paper, let the meaning stay in the air, and rest softly in the tender idea of a universe made of relationships. Somewhere in the small pocket of the world where you are tonight, the table is still there. Your hand may still be resting upon it, or your cup may still be sitting quietly upon its surface, or the small pool of lamplight may still be pooling gently across it, in the way lamplight does when the night has drawn in and there is no one asking anything of the room. The table has been there all along. It has held whatever you have placed upon it, softly, without complaint, throughout every strange thing we have wandered into tonight. And somewhere, in another quiet corner of your imagination, there is still a pond. Its surface has settled again. The ripples from the fallen leaf have long since spread to the edges and faded gently back into stillness. The reflected star is a little brighter now. The trees around it are darker against the deepening sky. The evening has gone on without asking to be noticed. And somewhere, still, in the room around you or in the room in your mind, there is a lamp glowing softly, with a shadow moving slowly on a wall behind it. And on a shelf, there is a small folded paper crane, keeping its patient watch. And on a windowsill, there is a small piece of crystal, throwing its own quieter shadow onto the floor. And on a table, or in a drawer, or in a box you have not opened in a long time, there is a letter, its little marks holding their little meaning, waiting to be read again on a quieter evening. All of these small, ordinary things are still here. They have been here throughout the night. They have held their places gently, while we have wandered into some of the strangest questions physics has ever begun to sit with. And they are, in their own soft way, the whole shape of the journey we have been on. Because everything strange we have visited tonight has been, in one way or another, a soft wondering about what quietly holds these ordinary things up. We began with the table and with the felt sense of solidity, the quiet confidence we carry through our days, that the ground will hold us, that the walls will stay, that the hours will tick gently past. And we let a small, strange question drift into the room. Whether the space we move through and the time we measure might not be the deepest layer of the world. Then we wandered to the pond and let the ripples remind us that a thing can be real and reliable and still not be the ground floor of what is. That warmth is real and yet emergent. That solidity is real and yet emergent. And that perhaps, in the same soft way, space and time themselves may be emergent, real, trustworthy, present, and still, at the bottom, arising from something quieter beneath. Then we sat with the lamp and the shadow it drew on the wall and let it lead us into the holographic whisper, the strange and beautiful suggestion that the three-dimensional world we live in might, in some deep mathematical sense, be encoded on a two-dimensional surface somewhere, that the interior of the world and the boundary that surrounds it might be two forms of the same soft story, that gravity itself, and perhaps space-time, may be the way certain patterns of information look from the inside. Then we turn to the folded paper and to the small, clean shape of the crystal, and let them lead us to the amplituhedron, the strange and lovely suggestion that geometry, pure shape, might sit even deeper in the world than space and time, that there may be, sitting quietly in a mathematical space of its own, a higher shape whose properties softly hold the answers to how particles behave, and that speaks those answers without ever needing to mention space or time at all. Then we came to the letter on the table and let it lead us into the picture of a universe woven from information. The picture in which the space between things is not empty, but full of quiet correlation, in which entanglement, that soft link between distant parts of the world, may be one of the threads from which space itself is woven, in which everything you can see and touch is a small pattern in an unimaginably large and quiet web of relationships. You do not need to hold all of that at once. You do not need to remember any of it, really. The shape of the journey is enough. From the table, to the pond, to the lamp, to the folded paper, to the letter, we have been asking in gentler and gentler ways the same soft question. If space and time are not the deepest thing, then what is? And the honest answer to that question tonight is that no one knows. Not yet. Perhaps not for a long time. Perhaps not ever, in the way that we are used to knowing things. But the wondering has taken on a shape. It has begun in the last few decades to look less like a wild speculation and more like a very quiet frontier. A frontier that a small chorus of physicists is patiently exploring from many different directions, in many small offices, on many long evenings, with a kind of care that is worth resting in for a moment. Let us wander now, softly, into that frontier, not to bring back any answers, just to visit for a while. The place where the wandering becomes most insistent, as we mentioned earlier tonight, is the Planck scale, the unimaginably small realm where ordinary space and time seem to lose their meaning. Physicists have known for a long time that if you follow the mathematics of the world down to that level, something strange happens. The smooth, continuous cloth of space-time, so obvious in everyday life, seems no longer to hold. The equations that have served us so well begin to give strange answers, or no answers at all, or the same answer many times over in ways that cannot all be right. It is as if the mathematics itself, at that depth, is quietly pointing beyond itself, whispering that there is something else here that we have not yet named. The natural first guess when confronting a place like that might be that whatever is there is simply more of the same, a smaller kind of space, a finer kind of time, a microscopic version of the room we live in. But the more carefully physicists have looked, the more it seems, softly, that this is not the right guess. That whatever is down there at the Planck scale is not a tinier version of ordinary space. It is something quite different. It is not made of shrunken distances and shrunken durations. It is made of something that only gives rise to distances and durations when it is viewed from above. What that something is, no one is quite sure, but a small number of quiet possibilities have begun to be sketched in the mathematics and in the imagination, and it is worth spending a few gentle moments with them tonight. Not to decide between them, not to advocate for one over another, just to notice how many different shapes the wandering has taken and to feel, softly, the family resemblance between them. One of these possibilities is called loop quantum gravity. It is the work of physicists who have, patiently, tried to take Einstein's soft, curved spacetime and turn it very gently into a quantum object. In their picture, space is not a smooth, continuous fabric, but a fine weave of tiny loops of geometry linked together into a kind of network. Each loop is unimaginably small. Each link between loops is a small, quiet relationship. And what we experience as smooth space is what this network looks like when you cannot see the individual loops. Zoomed out, the network appears as continuous space, in the same soft way that a very fine cloth, seen from across a room, appears as a smooth surface, even though it is made of countless small threads. In this picture, space is not the stage, space is the weave, and time too, in some versions of the picture, is knitted into the same fabric. What we experience as the passing of hours is the slow unfolding of this network, one small, quiet change at a time. That is one soft possibility. It is not proved. It has its own unresolved questions. But it is a careful, gentle, mathematical attempt to give a shape to what might be sitting at the Planck scale, and it treats space itself as a woven thing, made of small pieces of geometry, held together by their relationships. Another quiet possibility is called string theory. This one is older and grander in ambition, and it has spent a long time in the pockets of theoretical physics, patiently being developed by many careful hands. In string theory, the fundamental ingredients of the world are not, as we usually imagine, small points. They are small threads, tiny vibrating strings, unimaginably short, whose different modes of vibration give rise to all the different particles and forces we see. An electron, in this picture, is a string vibrating in one particular way. A photon is a string vibrating in another, and the whole variety of nature, all its different particles and different behaviors, is a great quiet music of vibrations. String theory has, in its long history, sat with the possibility that space-time itself is emergent, that it is not the deepest thing. In some of its versions, the strings live in more dimensions than the three we see, with the extra dimensions quietly curled up into small hidden shapes. In other versions, the very idea of space-time dissolves at the Planck scale, and something more subtle takes its place. It is a mathematically demanding picture, and one that is still very much a work in progress. But it too treats the world at the deepest level as something we cannot see directly, something that gives rise to the space and time of everyday life when it is viewed from a certain angle. A third quiet possibility is called causal set theory. It is a softer and more austere picture in its own way. In it, the universe is not made of loops or of strings, but of a great web of ordered events, little quiet points of happening, linked together by the relations of before and after. There is no smooth space in this picture at the deepest level. There is no continuous time. There are only these small, ordered events and the pattern of their relationships. And what we experience as space and time is what emerges when this vast web of events is viewed at a scale much larger than the events themselves. In this picture, the world is more like a story than a stage. It is a great sequence of small, quiet happenings, ordered gently by the relations between them, and the smooth flowing time we feel and the roomy space we walk through are the surface appearance of that ordered web when it is looked at from far away. These are three of the softer approaches physicists have taken to the question of what sits at the bottom of the world. There are others. There are still gentler ones being sketched in offices right now. There are older ones being patiently refined. And there is, importantly, no consensus. No one in the physics of our time is claiming with certainty that any one of these pictures is right. Each of them has beautiful pieces. Each of them has open puzzles. Each of them is a soft possibility being carefully explored by people who are more interested in getting things right than in winning an argument. What is striking when you sit with all of them at once is how similar their family resemblance is. In every one, the deepest layer of the world is not more space and time. It is something quieter, a network, a weave, a pattern, an ordering. In every one, space and time are the surface appearance of something more fundamental, expressed when many small ingredients are gathered together and viewed at a distance. In every one, the world you feel around you is real and reliable and honest, and yet not the bottom of the story. That family resemblance is worth resting in for a moment, because it means that even without agreement on the details, a broader picture has begun to form, a picture in which the ordinary space and time we live in are, in some deep sense, emergent. A picture in which the deepest layer of the world is a quieter, stranger thing for which we do not yet have a settled language. A picture that, whatever its final form, is likely to be a picture in which the room you are sitting in is a soft surface expression of something we can only glimpse from within. And this is where the quiet warmth of the current moment in physics really lies. Because we are living, whether we quite notice it or not, in one of those rare and gentle times when some of the oldest questions the human mind has ever asked are being sat with by patient people using tools that are unusually powerful. The questions themselves are old. What is the world made of? What is time? What is space? What holds it all up? These are questions that have been asked in one form or another since long before there were physicists to ask them. But the way they are being asked now, in the mathematics of the 21st century, is genuinely new. And the fact that we do not yet have answers is not a crisis. It is a frontier. There is something rather freeing in that, because for a very long time science tended to move by shifting from one confident picture to another. First, there was Newton's still theatre. Then there was Einstein's curved cloth. Each was, in its moment, held with great certainty. Each was eventually softened by the discovery of the next. And here, at the current edge, we are in a soft, in-between place. The old, confident pictures have been gently stretched. The new ones are still being sketched. And no one is quite sure, yet, which of the sketches will grow into the next great picture, or whether all of them are hints towards something none of them has quite named. To sit in that soft in-between place, tonight, is to be doing something quietly interesting. It is to be paying attention to a moment when the world is, in a certain sense, listening to itself. When human beings are patiently trying to hear what is quietly running beneath the ordinary. And to be one of the minds that is even a little curious about this, on a quiet evening, in a warm room, is a small gift. It is a way of being part of the wondering, a way of being one of the soft threads in the larger weave of the question. And it is worth saying gently, before we begin to land that this wondering does not take away anything you rely on. It does not take away the table. It does not take away the room. It does not take away the sky, or the passage of time, or the small, ordinary comforts of your evening. Whatever the deepest layer of the world turns out to be, if we ever manage to learn what it is, it will not undo the ordinary layer. It will not, please notice, come knocking on your door and ask for the cup back. It will not make the floor less trustworthy. It will not make the hours refuse to pass. If anything, the discovery that the ordinary layer is quietly held up by something deeper makes the ordinary layer more tender, not less, because it means that the reliability of the world is not a bare fact. It is a soft achievement, a quiet gift, arising every moment from a strangeness beneath. The floor holding you is not just a floor. It is a very careful and very quiet arrangement of relationships, doing its small work on your behalf in every second of your life. The walls staying where they are is not just walls staying. It is a great quiet pattern maintaining its shape, so that your room can be your room. The evening deepening around you is not just the passing of time. It is a soft unfolding of something we do not yet understand, expressing itself gently as the hour it is. To notice this, even softly, is to be quietly grateful to a world that has not been asked to be grateful to. It is to feel, at the edge of thought, that the ordinary is, in its way, a very extraordinary thing. That the table you are sitting at, or the bed you are lying on, or the sofa you are settled into, is not a small, dull object. It is a small, quiet expression of something old and strange. Something the whole of physics is, right now, patiently trying to understand. And you are, for the time being, one of the small patterns held up by that same strangeness. Your body is a little arrangement of information. Your breath is a little rhythm inside a much larger web. Your thoughts, tonight, are a soft pattern that has been walking through a certain sequence of images, from the table, to the pond, to the lamp, to the folded paper, to the letter, and now to the quiet in-between place, at the edge of the current frontier, where physicists are gently wondering what quietly holds everything up. You do not have to hold that. You do not have to remember it. You do not have to understand it in any strict sense at all. You are permitted to let it drift, softly, out of the sharp part of your mind and into the softer part, where thoughts go when the day is nearly over and the body is ready to rest, because that is where we are now, at the softer end of the night, at the place where the wandering has been walked far enough and the room is warm enough and the body is tired enough that it is time to gently let the whole thing settle. So let us come back once more to the very first image, to the table, to your hand upon it, if it is upon it, or your cup upon it, if it is there, or the small pool of lamplight upon it, if you have a lamp nearby, to the felt weight of your body in the chair, or in the bed, or in the corner of the sofa you have quietly claimed for the evening. The table is still solid. The cup is still where you left it. The night is still passing gently outside. Everything is as it was when we began. And beneath it all, quietly, without asking anything of you, there is something we are only beginning to understand. Perhaps a network of small loops of geometry holding the space around you in place. Perhaps a great music of tiny vibrating strings singing the room into being. Perhaps a vast web of ordered events unfolding the evening into the shape it has. Perhaps a pattern on a boundary somewhere far beyond the walls, softly projecting itself into the interior you are sitting in. Perhaps a shape in a higher dimensional space, patiently doing its quiet work. Perhaps a great quiet web of relationships, tying you gently to the walls, to the floor, to the sky, to everything else. Perhaps some of these, perhaps all of them, perhaps something none of them has quite named. We do not know yet. What we do know is that the world is here, that the table is here, that the cup is here, that the room is here, that you are here, resting quietly in the soft middle of everything, being held up in ways we are only beginning to imagine, by something gentle and strange. Let your shoulders soften. Let your hands rest wherever they are resting. Let the small muscles around your eyes let go. Let your breath find its own quiet rhythm, without you guiding it. The floor is holding the chair is holding you, the room is holding the chair, the building is holding the room, the earth is holding the building. And beneath the earth, and beneath the small distances, and beneath the passage of the hour, and beneath even the space you are sitting in, there is something soft, something old, something we cannot yet see, something that is perhaps more like geometry than like stuff, something that is perhaps more like a relationship than like a thing. Whatever it is holding you tonight. The lamp is still glowing, the shadow on the wall is still there, the folded paper on the shelf is still keeping its patient watch. The letter on the table is still holding its little meaning. The pond in your mind is still smooth. The star is still reflected in it. You are safe, you are warm, you are held. Let the room be a small pocket of arranged light in a very large and very quiet universe. Let the night be a soft covering laid gently over the world. Let the wandering rest, for now, at the edge of the room, curled up like a familiar cat in the shadow, not asking anything of you. The table is solid. The cup is still there. The night is still quiet. And somewhere, quietly beneath everything, geometry is humming. Somewhere, quietly beneath everything, small threads of relationship are holding the world together. Somewhere, quietly beneath everything, whatever it is that is really there is being what it is, so that you can be what you are in this small, warm room, on this quiet evening, at this soft hour of your life. Rest now. The world is still here. The room is still here. The floor is still holding you, and underneath, gently, something strange is holding the floor.